Now, the whole purpose of having the change of base formula is so that we can solve exponential equations that we could not solve by using same base, or that might be a little bit more difficult solving on a graphing calculator, okay? So this is going to give us a way to algebraically solve instead of just relying on a graphing calculator when the answers don't come out to simple things from change of base, from same base. All right, so for number 5, we have 18 equals 4e to the 10x. Okay, so the first thing I want to do is I want to isolate the exponential piece. So the exponential piece is just the e to the 10x. I want that alone. So I'm going to divide out the 4 from both sides. Okay, and that's going to give me 18 over 4 reduces down to 9 halves. You can write it as 9 halves, or because that's a decimal that ends on its own, we can write that as just the decimal 4.5. Okay, decimals are okay to use as long as we're not rounding in the middle of the problem. We don't want to round until we get to the very end. Okay, so now that I have this exponential equation, I want to convert this to logarithmic form and then see if the change of base formula is necessary. Now, because there's a base of e here, we know that that's a special logarithm, so we can think of it as log base e, but the easier way for us to write log base e is just to write natural log. So this is, again, log base e of the answer piece, 4.5, is equal to the exponent. Remember, the whole purpose of a logarithm is to isolate the exponent. And our goal here is to solve for x, so our next step is going to be, well, let's go through and let's divide out that 10. So we're going to have that x is equal to the natural log of 4.5 divided by 10. Now, if a problem asks you for an exact value answer, this is where you would stop. But most of the time, it's going to ask you to give it a decimal approximation. So we're going to go to a few decimal places. Now, the important thing, again, is the parentheses. There will be parentheses around that 4.5 before we do the divided by 10. So if we go on our calculator and do natural log of 4.5, take that and divide it by 10, we get 0.1504. Okay, so there's our final answer for problem number 5. Now that one didn't require change of base because it was a natural log problem, okay? But this next one will most likely require it because I don't see a base e and I don't see a base 10 anywhere. Okay, so again, the first thing I want to do on each of these problems is I want to isolate the exponential piece. So looking at this, this is the exponential piece, so that's what I want to be by itself. So I'm going to divide by 25 on both sides to start off. All right, now 12 over 25, again, that decimal ends on its own, so it's okay to use the decimal. You can leave it as 12 over 25, or you can do 0.48 instead. And that's equal to 3 to the x plus 1. Okay, so now I want to convert this to logarithmic form. Okay, so logarithmic form, this is going to be a base 3 problem. So this is log base 3 of the answer 0.48 is equal to the exponent expression, x plus 1. Okay. Now, I need to isolate the x by subtracting the 1. But I also need to convert to something I can plug into the calculator to do this. So I need to use the change of base formula as well. So the change of base formula will be log tall, or log of the inside number, divided by log small, or log of the base number. All right, and then I have my minus 1 is equal to x, okay? Now again, parentheses are super important with this. So there are parentheses around the 0.48 and there are parentheses around the 3, and then we want to do the subtract 1. So do your change of base first, hit enter on your calculator, then hit subtract 1, and you should end up with a final answer of x equals negative 1.6681. So those are our first 2 examples in solving equations. Let's look at 2 more. Problem number 7. Now, we alluded to this problem a long time ago, and we did it with a graphing calculator because there was no way to make 2 to the x and 3 have the same base. But now what we can do is we can just convert to logarithmic form, which we should be fairly comfortable doing at this point. So we now have log, the base in this problem is the 2, the answer is 3, and the exponent is x. So there's no extra work I need to do to isolate the x, just putting it into log form got the x isolated. But I do need to go through the change of base setup. So this is going to be log of the inside value, log of the tall number, divided by log of the small number. Okay. And again, parentheses will be important every time you do change of base. Put parentheses around the numbers before you hit the division sign. Okay, this will give me that x is approximately 1.5850. Okay. All right, one more. Now again, because I see base e, I'm going to do this with natural log instead of a regular log. Could I use a regular log? Absolutely, but it'll be easier if I use the natural log because there's a natural log button. So this is going to be the natural log of the answer 45 is equal to the exponent, x squared. Okay. Now I need to solve for x. And in order to solve for x here, I need to square root x squared. So I need to find the square root of this value, and I need to consider that it could be a positive or negative. Okay, so the two possibilities. So on your calculator, you're plugging in plus or minus square root of, and then inside of the square root, actually let's shorten that up a little bit, make it look like it would on the calculator. When you type in the square root on the calculator, you get a set of parentheses, and then you're going to type in natural log parentheses 45, and you're going to have to double close the parentheses there. And that's what our x will be equal to. Don't worry about the plus or minus. You're just going to write the plus or minus yourself. So this comes out to x equals plus or minus 1.9511. Okay. Now there's one more example we're going to do, but I'm going to make a separate video for that because it is a longer example. Okay, last problem's coming up.